AB Calculus, Notecard 37, finding increasing and decreasing intervals. This is lesson 37 in the Notecard series inspired by Stacy McMullen, formerly of the Dowson Penn School District, who developed this Notecard system. Finding increasing and decreasing intervals. This is a follow-up to Notecard 36, which introduces what increasing and decreasing intervals look like. And I happen to introduce some of the analysis in the Notecard 36 lesson that we're going to further explore today. To find the intervals where f of x is increasing or decreasing, we find the critical numbers. And we've gone over what they are in prior note cards. We're going to use that here for finding increasing and decreasing intervals. We set up test intervals on a number line. So we're going to mark these critical numbers on a horizontal number line. Find the sign of f prime of x, or the first derivative function for each interval. And if f prime of x is greater than 0, then f of x is increasing. Use arrow. If f prime of x is less than 0, then f of x is decreasing. Use arrow. And what I introduced in our prior lesson is if you have a f and f prime of x, we put a row here, plus, minus, and we put a increasing value here, a decreasing value here, and then our last two are going to be concave up, concave down. And then below, on the f prime row, we put plus, minus, and then increasing, decreasing. So what this tells us, our analysis piece is going to center on this part of this analysis chart. It says if we determine where f prime of x is positive, we have discovered where the original function, f of x, is increasing. If we find where f prime of x is negative, we discover where the function f of x is decreasing. Okay, let's go over some problems. Now, find the intervals on which the function is increasing or decreasing for f of x equals x cubed minus 3/2 x squared, justify. In our justification, we can really pre-justify. We can say pre-justify increasing on, okay, I'm going to leave just because f prime of x is greater than 0. Okay, decreasing on, why? Because f prime of x is less than 0. So now, having pre-justified, we're going to be able to do the analysis and just plug in. Now, I left more room in case we have more than one interval that we can place or need to place in these blanks. So let's go ahead and do this. F prime of x, we're finding our critical numbers now. We're taking a first derivative. We get 3x squared. And this one here, we're going to say minus, we're going to have the 2, you can put 3, minus 2, because it's multiplied by 2 here, times 3/2, and then we have x. And 2 over 2 cancel, so now I'm going to set this equal to 0. So 0, to find critical numbers, we set f prime of x equals 0. So you have 3x squared minus 3x. And we can factor out 3x. And if we factor out 3x, we get x minus 1. So we have x is equal to 0 as a critical number, and x equals 1. So I'm going to just put these critical numbers and critical numbers, x values, where f prime of x is equal to 0. Now we go and we found our critical numbers. Now we set up test intervals on number line. So I'm going to draw a number line here. And our critical numbers are 0 and 1. So here's 0, and here's 1. So that's going to be that. Let's go back and look at our guide. Set up, okay, we did that. Find the sign of f prime of x for each interval. And to do that, I'm going to put above this number line f prime and below f. And what we're going to do is access our little f prime chart that I'm writing here. Remember, plus, minus, increasing, decreasing, concave up, concave down. And then where f prime is increasing, we have a plus sign. Where f is increasing, we have a plus sign. And where f is decreasing, we have a minus sign in f prime. And then we have like this. And there's going to be an f double prime row down below here. Let's get on with this. Okay. From negative infinity, we've broken this up, essentially, this number line into 3 intervals: less than 0, between 0 and 1, and greater than 1. So we can go to our original function here, which is this 0 here is going to be f prime of x that we've set equals 0. So if we have a number less than 0, we have a negative times a negative. And what's a negative times a negative? Negative times a negative is positive. And so we go and draw, it says draw arrow underneath, right? So use arrow, f prime is greater. So we're going to go draw the arrow going up underneath, and we're accessing this chart in the lower right to do that. Okay, and these specifically that I'm circling right here. Okay, between 0 and 1. Well, between 0 and 1, we're going to be, x is going to be positive, but x minus 1 will be negative. So we have positive times a negative. The original function f of x is decreasing over this interval between 0 and 1. And then the last interval is going to be greater than 1. So greater than 1 is going to be positive times a positive. And so we're increasing on the interval from negative infinity to 0, and also we put union from 1 to infinity, and we've pre-justified because f prime of x is greater than 0. And we are decreasing on which interval? Between 0 and 1. Why is that? Because f prime of x is less than 0. So a lot of good justification going on here. I'm going to go now to problem 2. The function f is given by f of x equals x to the 4th power plus x squared minus 2. On which intervals is f increasing? I'm going to just pre-justify again. I'm going to say f of x is increasing on, I don't know where exactly. Leave myself a lot of room in case I need 2 intervals or so. But the reason will be because f prime of x is greater than 0. So now we're going to go and take this function and find the first derivative. F prime of x is equal to 4x cubed, and then the derivative of x squared is going to be plus 2x. And now setting this first derivative equals 0, we can factor out a 2x, and 2x times quantity, that's going to be 2x squared, right? Plus 1. Is that right? So for this, we're going to get x is equal to 0. Now, can we make this thing here equal to 0? 2x squared, 1 is equal to 0. If we subtract 1, we have 2x squared is equal to negative 1. Divide by 2, we have x squared equals negative 1/2. There's not a real number solution for this. So there's no solution based on this. So really, we are looking at x equals 0. So now we're going to make our number line. Just put a 0 here. And above we put f prime of x. And below f, and we're just going to examine left of 0 and right of 0. If we take a negative number, we know we're going to be negative, right? Because this 2x squared plus 1 is always going to be positive. So we have a negative times a positive, decreasing. And then to the right of 0, we have a positive times a positive, so we are increasing. So we will say increasing on 0, comma, infinity. Why? Because f prime of x is greater than 0, and that's it. Next, 3. Where are all the values of x for which the function defined by f of x equals 20x squared minus 3 times e to the negative x power is increasing? So again, f of x is increasing on interval. And I'm going to leave a lot of room just in case we need more than one interval, because f prime of x is greater than 0. So now we're going to just try to find the derivative of this. We will find it. And we can treat this different ways. We can distribute, or we can just use a product rule and have like u and v. So the u function would be like x squared minus 3, and the e to the negative x would be v, and make a box like I've done here before. And I'll have u prime, v prime. So here we have our u is going to be x squared minus 3, and our derivative of u is going to be 2x. And for this one over here, we have e to the negative x, and v prime is going to be negative e to the negative x power. So that's using the chain rule. So we will say f prime of x is going to be equal to, we'll say 2x times e to the negative x power, and that's going to be plus, but we are subtracting here because we have minus e, so say minus e to the negative x times quantity x squared minus 3. And factoring, how can we factor this? It looks like we can pull out an e to the negative x power. So f prime of x is going to be e to the negative x power times 2x minus x squared minus 3. Okay, so just kind of simplifying here, I'm going to set this equal to 0. So we have e to the negative x, and what we're going to get is negative x squared plus 2x, and we have minus minus plus 3, and we could factor out a negative sign. 0 equals negative e to the negative x, and we'll have times x squared minus 2x minus 3. And that's going to be 0 is equal to negative e to the negative x, and we're going to have 20x, let's see, and we're going to have plus minus, and we have negative 3, so, and negative 2x, that's bigger, so that's going to be 3, and that's going to be 1. So our critical numbers here are going to be, if we set negative e to the negative x power, we can't get this thing to be equal to 0. So we're not going to have a critical number based on negative e to the negative x power. So that can never be 0. But we know that x plus 1 gives us a 0 of x equals negative 1, and x minus 3 gives us a 0, x is equal to 3. So these are our critical numbers. Okay, so now we can set a number line here and put our critical numbers down here, negative 1 and 3, and we put f prime up here on top and f down below. And to the left of negative 1, what do we have? Well, we're going to have this one here on the left is always going to be negative, right? Because we have negative e to the negative x, e to the negative x is always positive. So we have a negative times a negative times a negative, and negative times a negative times a negative is negative. So we are decreasing from greater than negative infinity to x equals negative 1. And now if we go between negative 1 and 3, we have negative and if we just plug in 0, right? Positive, negative, negative, positive, negative, positive, right? So we are increasing, and greater than 3, we have positive, no, that's going to be negative, it's always going to be negative, negative, positive, positive, and negative times positive is negative. So f of x is increasing on negative 1 to 3 because f prime of x is greater than 0. See, pre-justification. Next, identify the intervals on which f of x equals quantity x minus 2 to the 2/3 power is increasing or decreasing. Justify your answer. So we're going to say, again, pre-justification. F of x is increasing on, and I'm going to leave a lot of room because f prime of x is greater than 0. And also f of x is decreasing on interval or intervals we don't know because f prime of x is less than 0. So we're going to find our first derivative here. And f prime of x is going to be equal to 2/3. We're going to have quantity x minus 2, and to the power of 2/3 minus 1, so we're going to get negative 1/3. Okay? So now we can just rewrite this if we want to as 2 over 3. Negative 1/3 power is the cube root of quantity x minus 2 down here. And we can set this number equal to 0. Now, for a critical number, it doesn't really have to be exactly where that is 0. In this case, we can set the denominator equal to 0, because when we set the denominator equal to 0, we will know where this function is undefined. So I'm going to say 0 is equal to 3 cube root of x minus 2, and for this to be a true equation, x is going to have to be equal to 2, right? That's going to be our solution. And we could divide by 3, cube it, and so we're going to x minus 2 equals 0. And so this is going to be our single critical number. And again, this is one where we didn't get where f prime of x are equal to 0, but rather where f prime of x is undefined. Okay, next, we go ahead and set up our number line with our single critical number, and we're going to put f prime up above and f below, and to the left of 2 we're going to plug in, and we can plug in right here our original value, and to the left of 2 would be like 0, so we would have 2 over 3 times the cube root of negative 2. Well, the cube root of negative 2 is going to be negative, so we know that left of 2 we're going to be, f is going to be decreasing, and if we put in a number bigger than 2 we would have a positive value here, and so there we are. And so f of x is increasing on 2 comma infinity. Why? Because f prime of x is greater than 0. F of x is decreasing on greater than negative infinity to up to 2, because f prime of x is less than 0. That's it for us today. I hope this has been helpful to you. Good luck, and thanks for viewing.